ranking and then we lost it. If you look at the last 10 years, we have always been in the top 10, all right? So we really value the innovation, and you will see that both on the MSME and the PhD program, with our faculty members, many of our students can participate into the innovation, having names in their US patents and all, okay? Okay, so I wanna simply introduce, I introduce myself, so let's go here. So you can see this is who I am. Our department chair, Rajiv Dubey, he will be joining us. He actually has a class right now. Towards the end of this presentation, you will see him as well, okay? We have this undergraduate program director, academic service administrator, Ms. Crane, who just spoke to you. And we have another academic program specialist, Melissa, all right? And I think that just to put a context how big our department is, if you look at the total undergraduate student population, we have close to 1,000 undergraduate students. So that's fairly big for considering the faculty size of 26, all right? But looking at the graduate program, we have right around 70, it fluctuates, master's students, MSME students, and we have right around 50 PhD students. And as I mentioned, we have 26 faculty members. And it is important to note that our students come from over 40 countries, right? So we have pretty much all the states represented. In addition to that, 40 countries represented in our program, all right? And these students are both in the MSME program as well as the PhD program, all right? And today I'll talk a little bit about the MSME program, then I'll talk about the PhD program. What is the general differences? It's not just applicable to our particular program, but I think it will be good information for you to decide whether you want to go into the graduate school, whether MSME is the path to go, the PhD is better for you. Should I do that first? Should I go directly to PhD? I'll try to give my opinion on these to you, all right? Let's start with the MSME program. The MSME program actually has two paths, all right? The two paths is this. The first is the MSME with the thesis option, all right? I'm sure you heard about the name thesis before, right? And the second option that we have is the students that can go through the MSME without the thesis. So they will be taking more courses to compensate for the thesis work, and they will be earning an MSME degree. One thing to note is that regardless of which path you take, you get the same diploma, right? But the experience is slightly different. And I want to, from the get-go, I want to share my opinion on which path a typical student takes. For the MSME with thesis option, my recommendation is if you want to go further in your studies to the PhD, it is actually a good idea to have a thesis experience, because when you apply to our school or other schools for the PhD programs, you look much more competitive because you have an experience and the faculty members will be much more comfortable in picking you up, all right? Having said that, this question I get a lot is, okay, I'm doing a non-thesis. I only took a bunch of courses. Well, bunch is 10, not, you know, like undergraduate students, not a lot, but I took 10 courses. Am I out? Can I not have a PhD? Can I not go to the PhD? Actually, I had a call like half an hour on this topic, right? So the answer is no, you can continue to PhD. It's just a simple preference of the faculty members, all right? But the typical student who goes to our non-thesis and takes 10 courses is the student who is a much more suitable candidate for the industry. That's what we recommend, all right? Again, it may depend on your personal, preference, all right? And I don't want to talk a lot about these particular requirements. It's too much in-depth information, but just to give you an idea. So we have compared to an undergraduate program, you can see that the total credit hours is 30. And so it corresponds to 10 courses, assuming each credit course is 3 credit hours, which is pretty much what it is for our department. And the thing that I want to highlight over here, specifying this is the required course, that is the required course, etc., is to say that we have flexibility, all right? In an undergraduate program, wherever you are currently, what happens is you have a flow chart, right? One version or the another version. You kind of follow all these flow charts, and you only have like a couple course opportunity at the end to pick up for technical electives, right? The rest of the courses really depend, just specified to you. You have to take thermodynamics, then the fluid mechanics, then the heat transfer, right? So it's not as involved with the required courses as a typical degree when you look at the MSME, all right? So we require 2 courses. This is more like a graduate version of this mechanics of solids type of course, right? It has different names, but we call it mechanics of solids over here. and no need to explain, but it's advanced thermodynamics, like a graduate version of the thermodynamics is required for all the students. And we ask students to take one mathematics course and one course from the specialization area, robotics, dynamics, and control. So you can see you have option over here, so we don't even specify which course you must take. I'm interested in robotics. Please go ahead and take the robotics course. I want to have the controls experience. I want to, I don't know, look at the design of the control systems of some robotic systems. Well, go ahead and take the controls or vibration dynamics, same idea. But what is important over here is you have six courses left out of 10, right? So I specified only 4. The 6 is up to you. And it's not only like a technical elective, but we have opportunities. For instance, you can work with a faculty member. Let's say that I'm interested in fluid mechanics area. This is my special area, so I'm giving an example from that. And let's say that I'm interested in cardiovascular fluid mechanics. Well, we have a professor on this. It's his career, right? So you take a course from him and you work with him one-on-one. There's no like class attendance. It's more like working on a particular project that you decide to work on, and you get credit towards your graduation. So it's a pretty nice thing that I recommend many of our students to do. Plus, I'll talk about the internship in a moment, but I always recommend students take internship, and I credit students internship like up to 6 credit hours can be earned by having 2 internship experiences, right? And many of our students go through the internship experience, both domestic students as well as the international students, okay? Plus, well, I'm gonna go to industry, let's say, right? I wanna pick up some courses from the industrial engineering department so I can prepare myself better for it. Sure, please, up to 2 courses can be from outside the department. And I recommend courses such as Lean Six Sigma, where it's related to manufacturing, which is very closely tied into our department, right? So this is in general, very briefly, what our MSME program is. And in the next, I want to talk about the PhD. Again, without going too much in depth, I can send much more information to you if that's what you want, okay? So looking at the course numbers, actually, it's not much more hassle to go through the PhD, because that's not where it's at, right? So the information about the PhD is not really related to the courses, to taking the courses, getting learning from the courses, not really that. It's more like looking at the dissertation, selecting a large project, you're working with a faculty member, you spend majority of the time in the lab working. It can be experimental, it can be simulation, it can be theoretical, some kind of a project. So that's the more important part of the PhD program, all right? And students ask me about this, so I'm gonna, from the get-go, we'll share it with you. So if you do an MSME in our program, and if you want to continue the PhD, so I mentioned you take 10 courses, so all of them, as long as they are real courses, not internship or independent study courses, will count towards your PhD. So for a student who actually starts from the master's program and continue the PhD in our program, they take like 2-3 additional courses, right? In a typical sense. And you can see there's significant overlap between the courses required for master's and PhD, like applied elasticity, advanced thermodynamics. If you're doing masters, you already have them. And you have mathematics 1 or 2 you picked up in the MSME, but in here we require both, okay? And it's similar to the, we have in the master's program, you need to take a course from this specialization area so that we prepare you for the future, right? We feel this is where the future is going. We want to make sure you're just at least exposed to it, okay? And similar to the master's program, there's 7 courses remaining. So these are actually decided upon by you and your major professor, okay? So if you're doing a PhD, you're going to have a major professor who will be basically the PI or the primary investigator of the laboratory that you're in, right? So that I will be your academic advisor. I'll be able to help with the courses and all, but which particular course is much more aligned with your dissertation topic will be decided with your major professor, okay? And I get this question a lot, so I wanted to say over here, currently all the students in our PhD program are supported with the full tuition waivers and TA or RA and some kind of combination between the two. We support the students, right? And I'll talk about the opportunities for the masters, but typically it's much more limited. The majority of the funding that we have focused towards the PhD student recruitment, okay? Just want to highlight that from the get-go. Okay, so I want to give you a little bit of information about the courses that we offer so you have some idea, okay? Again, in the undergraduate curriculum, you may be used to seeing like the courses being repeated in the fall and spring, right? So in the graduate program, that's not really the case. So I highlighted the 2 core courses. These 2 courses are repeated every spring and fall, but the remaining, this yellow technical elective courses are not repeated. So we have, like, let's say, this is the number of courses that we offer this semester is slightly lower than usual due to COVID, right? Because we have some lab-based courses that really requires a hands-on experience. But we have, like, typically 10 additional courses in the spring and 10 additional courses in the fall. So you have almost like 22 courses to pick from in case that's what you want to do. And that's only from our department. Again, you have options from the other departments as well. Okay. And just to give you some ideas, robotic systems, advanced materials, CFD, biofluidics and bio-inspired design are some of the courses that is fracture mechanics are popular courses that goes all the way to its cap. Okay. Okay. So I mentioned the internship. I gave credit to the MSME students as well as the PhD students too. Okay, I just want to clear that internship credit towards graduation is also available for PhD students. And I recommend, regardless of which school you end up with or whether you choose to go to graduate school or not, internship is so important. All right. That's my experience going through this. My position in the department. I've seen many students, hundreds of students, and it's very important. Okay. So I highly encourage students to have an internship experience. And in our program, I wrote over here close to a dozen students in a given semester. And actually, to be honest with you, in the COVID time, this number did not go down significantly. Okay, it may go down from that dozen to 10 or something, but it's still, significant number of students are doing internships, including this very semester too. Okay, and most of the internships can be from in the Florida or in the any other state. Okay, we are not just focused to here. And I put some names that recently, our students have internship over there. Like a student at Tesla in last year, and he now has a position there as a full-time employee. Similar thing to FedEx, Fiat Chrysler. So it's more like Jeep, right? And Michigan. So we have students working there, etc. All right. So these are some opportunities available to you. As far as the TA and RA opportunities for the MSME students, the first line is kind of key. Opportunities are competitive. Okay, RA stands for the research assistantship. The research assistantship goes through the individual faculty who they will talk soon. Right. So in this presentation, about 20 minutes or less, professors will start to talk about what they do, what kind of openings they have there in labs and etc. But think of them as like small businesses. Each of them is running a small company. It doesn't go through me. You have to go to each individual small business and ask them whether there's an opportunity available in their labs, because they get the funds themselves and they fund their own students. Okay. On the other hand, the TA or the teaching assistant goes through our department or myself. We typically give an opportunity to students in the second semester, not from the first semester. And it still is kind of competitive. And I gave you a number over here, just an estimate, obviously. But I say that from the master's standpoint, I get at least 10 requests per an opening for a master's. Right? So there's a significant interest in the TA. And I try to give priority to the students who are doing a thesis with a professor, because we value that opportunity that you're going through, because you can publish papers. You can go to PhD program. So that's the path that, we as in the academia would like you to proceed. Okay. So, okay. Now let's say that I'm going to the MSME or PhD. I sometimes hear this from the students. Okay, I'm good. I get into the MSME or PhD, whichever is your preference. I'm good to go. Well, this is just a step, right? At the end of the day, this is not a goal. This is just a temporary time period where you learn a lot and then you apply it, right? And the next thing is to basically graduate and have a placement. And I want to talk about that a little bit, right? Student job placement upon graduation. And I'm mentioning over here, I picked up these companies that we have students working from the graduate program, I would say in the last 2 years or so, give or take, okay? So you can see we have students working at global companies like Tesla, Apple, Intel, Boeing, Cummins, Caterpillar, etc. So you can read the list yourself. But the point that we are trying to make over here is our graduates are having positions throughout the US as well as international. Some international students choose to go back to their own country. We have multiple students being a faculty members their own country because that's what they prefer to do. We have faculty members that is in the United States as well. So just to give you an idea of what you are expected you can achieve by the end of this studies with us. Okay, so I mentioned about the TA, I mentioned about the RA. Well, money is important, right? Maybe I don't have funds to fund myself, so what am I gonna do? I check with the professors. Unfortunately, they don't have RA position available to me. Students talk to me and I say, you know what, I'm doing my best, but there's no position available, right, for the TA opportunities. So what are you gonna do? Well, just want to give you a general idea. I'm not going to read this whole thing line by line, but the first green font that you see here is aligned with what I want. Like, go talk to the professors, okay? And the first thing I recommend, again, regardless of which school you want to go to, is don't show up to the professors' offices without knowing what they are doing, all right? So do your homework first. Go to their website, look at the recent publications, go to Google Scholar, at least have some idea of what they're doing, because you can imagine how many emails do we get per day, not per week, I'm talking about per day, from the students who wants to, some kind of a position in our labs. So it's kind of important to differentiate yourself from the others. Do your homework, know what the professor is working on. It's a much better response if you go to a professor, say that, hey, Professor X, I noticed that you are working on this and I'm interested in doing this kind of research from this field, right? So that's a very different conversation than just showing up to the professor, hey, professor, what are you working on, right? Because that information is available to us, okay? Like I mentioned to you, so I'm interested in funding students who are working in a research group, contributing to the academic publishing of their work and etc. Okay, and I mentioned over here in the blue font, but you're not limited to mechanical. So we have students actually graduating this semester who are applying to graduate. They are working in a lab in the chemical engineering department. That's perfectly fine. You're getting your degree in mechanical, but the professor who you're working with in the chemical engineering department, that will be fine. There's no problem with that. Okay. But it may be important to keep in mind that they may prioritize their own students, because they may have better background. But it really, mechanical is, as you know, I don't have to sell it to you, but it's a pretty broad field. So I believe there will be, complementary experiences. It's for doubly, we have students working in a doubly lab and getting a mechanical, chemical. Yeah, I gave that example, etc. Okay. I'll be happy to send you this presentation. At the end of this presentation, I'm going to share my email with you, so you can email me in case you want more information, and I can share these links with you. But we have a basically bunch of different fellowships available to the students. Okay, typically what happens with these fellowships, it goes directly from the student to these fellowship opportunities. It doesn't go through me. If there's like a letter that you need from the support of the department, I'll be glad to help you with that. But it is more like individual initiated effort. And we mentioned two different things. And this is not coming from our side, but if you're an international student, there may be some limitations, okay? Because some scholarships may require the citizenship, okay? That's something to note. And I want to give you another list. Again, I will send, I'm not going to read these, right? But some scholarships also require, in addition to US citizenship, we may require Florida residency. That's up to the scholarship. Again, I can send these links to you, all right? And I want to also read about these other areas of scholarships. We have like USF Women in Leadership and Philanthropy, African American scholarships available, accessibility scholarships, Black Leadership Network, Latino Scholarship Program, LGBTQ+ scholarships. So all sorts of different scholarships is available, okay? And you can see where you can link that, and USF grant opportunities, as well as, I'm sure many of you is aware of this, but the financial aid is also there for the graduate program. It's not just for the graduate, undergraduate program that you are graduating from, okay? So this is the general thing. And I want to like a additional bonus information. My time is like until 4:25, but I'm going to take a little bit more additional time. And I want to talk about these helpful tips. This is what we observe, because the thing is, like I mentioned to you, whether you're doing an MSME or whether you're doing a PhD, or maybe you don't even choose to go to graduate school, what I'm listing on this page is applicable to you, right? And I'm basically sharing with you what my experience has been going through this academic advisor of hundreds of students, okay? Obviously, it goes without saying that you need to have a good GPA, right? I mean, everybody knows that. It's not, I don't have to share that with you, right? I mentioned the first bullet point previously. The internship experience is very valuable. Okay, companies like candidates with experience. Okay, and I mentioned over there in their mind, because I'm not saying that that's right or wrong. I'm just stating what it is. You will be easier to train, right? Because considering that a position, how much it costs for a salary wise, right? Plus the benefits, hiring somebody, you're coming in as trained. So you can, from the day 1 or day 10, whatever, you start really being productive and contributing to the bottom line of the company, as opposed to if they hire you from, think about Tesla or FedEx, right? If they hire you, it's going to take quite some time for you to get up to the speed, right? So that's an advantage, and I can see their point of view from this. Okay, so the second one is important. I see from many of the mechanical engineers, they say that, you know what, I want to do experiments, bring me the experiments. I want to do experiments when I go to industry. I want to do this. I'm in the fluid mechanics, so I'll give you examples from, I want to do some tests in the wind tunnel. I want to do this. I want to do that. Yeah, that will be fine, but you will not be able to do a trial and test kind of run in a wind tunnel, because hourly cost, I'm not talking about like a Boeing kind of thing, but I'm talking about more like a car, like a much smaller than a plane, but hourly is like 1,000 or more per hour, right? So it easily goes to 5 digits just to get some kind of a data, right? So you're not going to be able to test. What is important is you have to do some kind of a simulation first to get your optimal design, and then you will be able to test your optimal design in a wind tunnel, as an example. Okay, and I've seen this. Students bring me their CVs. I see this a lot, and I look at it, and the student. I rarely see a student who doesn't list these. ANSYS, SolidWorks, I know it. But here's the thing. Certification is important to me. Okay, certification, because that will separate you from every other applicant. Okay, and I gave you some examples over here. It doesn't go through us, but LinkedIn Learning, EDX, those kind of resources are available. And obviously, you can contact me. I can give you some more information about a particular software. Okay. Having a research experience is another thing that I mentioned, and I also mentioned that, let's say that there's no position available in the lab, you can volunteer, you can take an independent study with a professor, so it's not an excuse that there's no RA position available to me, right? So you can volunteer, you can take an independent study. That's a course that's going to contribute to your graduation. Okay, so keep this conversation with the professors going. Okay, that will be my recommendation to you. Also, the fourth one is I see a lot. It comes from undergraduate too. It's not unique to graduate program. Students look at the courses and they hear from their buddies that, hey, this course A is easy. I'll get a good grade from course A. Well, you know what? May not serve you well. Okay. The important thing is you need to take the course that's relevant to your research interest or which particular industry that you will be going to, right? So, for instance, I gave the example of, again, from my field, CFD, right? We offer a course on CFD. So why don't you take that course if you're interested in going to, like doing some kind of related work in that field, right? So that's very important, instead of going to a course A, which is easier from another department or etc. Okay. And the fifth one is an observation. You have some kind of a professional social media presence. It is important. And I mentioned over here that, okay, you want an internship at Tesla, make sure you professional like or share their content, make a post about how this was your childhood dream. So it kind of works, all right? So those kind of things does work. Okay, I'm aware that I ran over my time, but I think these helpful tips will be appreciated from your side. And I want to give you my contact information. And I'm going to pass it to Celeste in case there's any other questions, because I don't see that particular board at this moment. So in case there's any questions, I'll be happy to answer your questions. Okay. Thank you for listening to me.
Dr. Goldigan, actually, the students may have missed the first 2 slides. If you want to review those, yeah,
okay.
Notified us. They were just able to tune in. So.
Okay. Yeah, of course.
We are accepting questions though, so while Dr. Goldigan reviews these first 2 slides, feel free to start submitting any questions you have. The Q&A session will end at 4:40. If nobody has questions, we'll proceed with the presentation.
And if you don't have any questions at this point, I'll go back to the last slide, so you can email me individually. I'll be happy to respond to your questions. But you missed the best slide of all. We were talking about how good USF is, so let me go over this again. So we are a large university, right? So we have over 50,000 students, okay? But we are dedicated to student success, that is important to note. And we are a high impact global research university, okay? And we have, looking at the US News and World National University rankings, comparing ourselves to other universities, looking at the last 10 years, no other public university has risen in the ranks more than us, right? So it's worth noting this information. And in about, 7 minutes, our faculty members will share with you their research experience, and you'll appreciate, you will be on the same page as me, okay, once you see what they are doing, okay? It's quite exciting from all different kind of fields in the mechanical engineering domain. I also mentioned the students can participate into these innovation experiences. So you can become a co-inventor in a patent that we are applying. Our department applies to many different patents yearly. And not only our department, it's coming from top to bottom. So you can see, looking at the entire University of South Florida, we rank number 8 in the nation among the public universities. And we also looking at the worldwide, we are 16. And as I mentioned when I was making a presentation on this, I'm not talking about one particular year where we were there and then we go down, right, in the list. I'm talking about, you're looking at the past 10 years in the nation, we're always in the top 10, okay? The ranking may change within the top 10, but we are always in the top 10. So we have been a productive university as far as the innovation is concerned, okay? And again, I'm not sure, some of the students may be missing this part, but, I mentioned about our department a little bit. I mentioned that we have about 100,000 undergraduates, so we are a very large undergraduate. You can look at there's Control L. So you can see we have 26 faculty, and looking at there are 1,000 undergraduate students, but at the same time we have a much less graduate student population, comprised of about 70 master students. It fluctuates from year to year, but 50, that's pretty stable, 50 PhD students, okay? So you can see over here, some of the faculty that we list over here is only doing teaching, so they're not participating into the research because the position requires that. It's called instructors. So looking at the tenure or tenure track faculty, they are very active, okay? So we have 50 PhD students, so per group, research group, looking at the research group, we have 4 or 5 PhD students per research group, and some of them is much more active than that, okay? And I also mentioned about how global we are. We have 40 countries represented in our program, both undergraduate, master's, PhD. It's a very international environment. It's a welcoming environment, okay? And I mentioned the names of the administration that we have, okay? So I think that's all I have, Celeste. I can continue presenting, but let's see whether there are any questions. Like I said, you don't have to, make a post of your question over here. Further down the road, you can contact me. Actually, let me go down all the way to the last slide so you can see my information right here, okay?
We do have one question from a user. Can you elaborate on the accelerated master's program, deadline of the application, and funding possibilities?
Oh, that's good. I like this question because I can answer, me. If I answer a question, it's called good question. Okay, let me answer this one. So here's what it happens, okay? Accelerated, just to give you an overall idea to, everybody involved in case they don't know what we're talking about. Accelerated master's program is undergraduate students take some technical electives, right? Every single undergraduate student. The accelerated program comes in handy from this end. We count 2 of the technical electives that you were supposed to take from your undergraduate program, and we replace them with graduate courses. And here's where the name accelerated comes in handy. Those 2 graduate courses, and those 2 graduate courses are these 2 graduate courses, by the way, Advanced Thermodynamics and Applied Elasticity. Those 2 courses will count towards both undergraduate degree as well as the graduate degree, okay? So if you think about it, in the undergraduate program, anyways, you were going to take the technical electives, 2 technical electives, right? So you're not really adding any course to the workload, right? But in the graduate, if you think about it, now I reduced the requirement from 10 courses to 8 courses, okay? So you, as a student who are participating in the accelerated program, you go and earn your degree with 8 courses. As far as the funding is concerned, we had students funded by the faculty as an array going through the accelerated program. We had students who we funded as a TA because there was, research activity was, appreciable amount of research was done. So that was what we did. So these are all possibilities. It doesn't exclude you from these opportunities. Thank you for the question.
Okay, I see one more question, but that is more of a private question, so we can reserve that for a private response. Otherwise, if anybody has any other questions, we're allotting like 2 minutes left for the Q&A section, and then we'll be proceeding with our faculty member presentation.
Oh, the exciting stuff is coming, all right? So don't worry, this was the boring stuff. The good stuff is coming, trust me on that one. Yeah, I see I'm looking at the questions posted. Yeah, some of them are more private questions, so please feel free to reach out to me from my email address. I'll be happy to, you know, answer your questions that you're posting in the, you know, list individual, you know, applicable to individual case as opposed to general, okay? Celeste, I would say let the fun begin, you know, let's get going to the presentation of the labs.
Okay, sounds good. So our first presenter is going to be Dr. Stephanie Carey. She will be representing the CART program.
Center. So we have a large center. It's a robotics center. Dr. Carey will talk more about it. Yeah.
Okay, looks like I'm live. Let me share my presentation here. Are you able to see my presentation?
Yes.
Okay, great.
There we go.
Okay, great. Yeah, so my name is Dr. Stephanie Carey. I'm kind of speaking about the center, our CART Center, which stands for Center for Assistive Rehabilitation and Robotics Technologies. And this really is a multidisciplinary center. We have engineers from all the different departments working with us, as well as other colleges across campus. And Dr. Rajiv Dubey, who's also the chair of Mechanical Engineering Department, as mentioned before, he's also the director of CART. This center has been around for almost 20 years in variations. So yeah, it's really an integrated center. So you can see here, College of Engineering, and then some of our research projects, we may have mechanical engineers working with computer science engineers and electrical engineers, and all working together on a project. And a lot of times our projects might come from other colleges. So we've worked with the College of Medicine. A lot of my research in prosthetics is working with the School of Physical Therapy, which is part of that college. We work with the College of the Arts, with music and dance. We do a lot of technology for injury prevention and assistive technologies in that college. We also work with the College of Behavioral and Community Sciences. We have some projects that look at the brain and brain-computer interfaces, and so sometimes we'll need scientists and researchers from that area. We also, though, not only do we have research, we also have education and service. So we actually, the center houses engineers all around the state of Florida that are consultants for people with disabilities. And so really they consult on assistive technology that might help somebody with a disability get back to work. So some of our research projects, as well as some of our educational projects, stem from that service component. So somebody in the community within the state of Florida might have some disability that needs some kind of adaptive equipment that helps them get back to work. And so, you know, we can put together our faculty members with students to make sure that we can get them those types of equipment. So that's what's really exciting for me working for this center, is you're not just working with mechanical engineers, but you're working with engineers and doctors and nurses and therapists and dancers. So it's really an integrative, multidisciplinary center. So I'm just going to share some of the research projects that we have in various stages. And some of these, you know, I'm more of the principal investigator, and some of these other ones I'm sharing are other faculty members. And so you can find out more information from them. But I do a lot of research on prosthetics and orthotics, and sometimes it's just looking at the biomechanics and testing out commercially available products and determining what's the best way to prescribe and train the users for these different devices. And sometimes it's more of a design project. So you can see over in the left, there's an orthosis that one of our students actually started as a capstone design project and then went on to get her master's degree with designing this kind of wrist-hand orthosis. And she was able to get a patent on it, and now she's started a company now that she's graduated, and she's working on other assistive projects as well, based on her experience as a graduate student here. And you can see here, we have a biomechanics lab. We have several on campus. This is kind of a typical motion analysis system where we can measure people's ground reaction forces and joint angles and those kinds of things. So this is another project we have specifically for vocational rehabilitation. So this is a virtual reality system to, again, help train people with disabilities to get back to work, or sometimes it helps with job placement. And so we have a screen that we can set up with virtual situations, or we have a head-mounted display there that you can see as well. And so they can work with their job coach to understand what's required of a job, or to practice that particular job skills before going to an employer and trying to get a job. And so we've been testing it with people with autism and traumatic brain injury, so more cognitive issues, but it's also being set up in a more portable system to try to maybe get it into some school systems to help people with autism at an earlier age. And then after they go through this program, they would have a job training certificate that they could then take to an employer to help with job placement. So we also have some robotic-based projects, and really these are led by Dr. Redwan Al-Qasemi. And he has some various robotic arms and things that are can be commercially available, but what he does in his lab is he adds some commercially available products and puts them on wheelchairs and adds some sensors and maybe a Connect and some various softwares, working with maybe some computer scientists, and makes these types of robots helpful for people with disabilities. So a lot of times it's there might be avoidance collision systems that help people in a wheelchair get in and out of cars and in and out of tight spaces, or it might be a robot that can be sent out to do tasks and activities of daily living if you can't do those yourself. And I know I'm running out of time, so I'll speed up here. So these are just some examples, again, of this autonomous pick and place, where you can actually tell the robot to go get it. It uses 3D computer vision, and we'll figure out how to pick up your different tablets and things if you are somehow confined to a wheelchair, for instance. We also have a Karen system, which is a computer-assisted rehabilitation environment, and I believe Dr. Reed's probably going to talk a little bit more about it. But basically, it's a virtual reality system that also has some biomechanics and a split belt treadmill and some force plates. And so we can really look at some biomechanics and how people move. And so I've been working with some groups and looking at military training and injury prevention. We also test the different prosthetic devices on here. And I've also been working with a former mechanical engineering grad student that now works at Johnson Space Center on looking at exercise devices for spaceflight. And I just want to mention that she had a NASA fellowship for her funding for graduate school. So that's something I could definitely help out as well with, looking at NASA fellowships as well as Florida Space Grant fellowships as a way for funding. So that's it for me.
Again, if you guys have any questions, feel free to put them in the Q&A and we can pass those to the right people. Next up, we have Dr. Mike Kai Wang.
Hello, hello. Les, can you see my screen?
Yes, I can. 1 second.
All right, good afternoon, everyone. You say 1 second?
Yeah, it's sending. There you go. You're live.
Okay. Hi, good afternoon, everyone. My name is Mike Wang, and I supervise the Nanomaterials, Nanomanufacturing, and Nanomechanics Lab. I'm an assistant professor of mechanical engineering and also affiliated with medical engineering here at USF. So our lab is called NM3L. We call it Nimble. That's our URL right there. So just type in nano.university. You don't need .com or .edu. It's just nano.university, and you can access our website, and that's my email right there if you have any questions. So that's our group. It's grown a little bit since then. That was the pre-pandemic days.
So our fundamental research revolves around 3 areas. One is applied engineering research, what we call beyond Moore's law. Moore's law being the law that kind of depicts the progress in terms of transistors and microchips. We also work in clean water as well as personalized healthcare, and this is based on new materials paradigms, especially what we work on in particular are 2-dimensional nanoscale materials. So these are materials that are extremely thin. In fact, they're some of the thinnest materials in the world, being single atom thickness. So we look at self-guided additive subtractive techniques and what we call angstrom scale or a sub-nanoscale precision, as you see here. So here you have we can manipulate material at atomic scale to change their properties. And based on that, we look at nanoscale a couple phenomena. So how does deformation and how does different stacking order as well as defects in these nanoscale materials affect their interfaces, their instabilities, as well as what we call incommensurabilities. So looking at the coupling between processing property structure relationships at nanoscale materials and using it for various applications. So this is what our focus is really on. It's these atomic scale materials. So a lot of you guys may have heard about this wonder material called graphene, and essentially graphene is nothing but just pencil lead, and that's isolated down to its atomic scale. And there's actually hundreds of similar types of materials that span everything from insulating to superconductors to magnetic materials. And we explore essentially the whole gamut of these materials and using them to make various devices that can supplant existing technologies across the electromagnetic spectrum. So a few topical research thrusts that we have right now, in particular some of them that are biomedical related with COVID right now are nanopore-based biomolecular sensing and sequencers. So currently the gold standard in COVID detection is what's called RT-PCR, real-time polymerase chain reaction. And this requires taking a swab, isolating for the COVID RNA sequence, and then amplifying segments of that and looking at the fluorescent signals. So that's a relatively slow and sometimes inaccurate technique, and it becomes very unreliable, especially now when we start talking about mutations, because essentially you have to know what to look for in order to get the answer you want. So when you have a lot of mutations, sometimes that can give you false negatives. Whereas for nanopore-based molecular sequencing, it's a brute force straight read technique where you're reading single nucleotide base pairs at a time. And so we're working on this technique using these 2-dimensional materials, and essentially what you do is you punch a hole essentially in these 2D materials, and you look at the translocation event of DNA or RNA as they go through a membrane. We're also looking at the interaction between these atomically thin 2D materials and their biologic systems, looking at their cytotoxicity and genotoxicity, because even though these materials may be benign, at the macro scale, when you change their shapes and sizes down to the nanoscale, there could be different interactions. So we're studying that. And we're also looking at phase change and defects in these materials, but what we call non-binary, non-silicon, or non-von Neumann architectures. So instead of having transistors that operate on a 0 to 1 basis, we use these things where they have essentially almost like an analog signal, and using phase transitions to do non-conventional computing as well as memory and storage. And actually using the same physics, we span a complete different length scale, and we're looking at using phase change nanoscale materials for solid state cooling and refrigeration. So this is actually a very interesting topic area that is a very new and kind of revolutionary technology, because everything that has to do with refrigeration or cooling or air conditioning is based on vapor compression cycles, and that's kind of a century-old technology. And we're looking at solid state materials phase change to essentially supplant that field. So that's it for me. If you have any questions, please reach out to me on my email, and check us out on our web address right here, nano.university. Thank you very much.
Okay, so thank you, Dr. Wang. Next up, we have Dr. Kyle Reed. I'm going to go ahead and send him live. So look at me. Melissa, can you try sending him live? Oh, wait, there we go. Now it's working.
Okay. So hello, everyone. Thank you for coming to this. So my name is Dr. Kyle Reed. You can look up more information about my website. It's listed at the bottom of these slides. Or if you forget what it is, just look up Reed Lab and USF and it will show up. So the two primary areas that I look at is haptics, which is the sense of touch. So every time you go into your pocket and try to pull out your keys and you can figure out which one it is based on touch alone, that's the sense of touch. That's the haptics that you're using, tactile interaction. I also look at rehabilitation. So looking in two areas of assisting with an impaired motion or restoring people's abilities. Now, haptics and rehab actually have a lot of carryover between the two because haptics is trying to make people's sensations that are healthy better. Rehabilitation is trying to take someone who has a disability and improve them. So I'm just starting at different points, but trying to make everybody interact with the world better. So one example of this is looking at a bimanual motion. So if you would like to try this, you can go and download the app called Pat and Rub. It's only on the Apple store right now. We'll look at porting it sometime. But this is based on the idea of, can you pat your head and rub your tummy at the same time? We're trying to see what you can do with two different hands. Now, that's the haptic side of it. The rehab side of it is you can actually use your healthy arm when you have had a stroke to rehabilitate your impaired arm. And so we're trying to understand these bimanual motions in healthy, unimpaired people, and then look at it for helping to restore motions in someone who's had a stroke or other impairment, particularly neurological in the brain. You'll notice that it's patented. A lot of the research that we do in the lab will go from fundamental ideation, and we'll build it, prototype it, and submit patents on it. So a lot of what we try to do is to bring that fundamental research and make it into something that could actually be practically used by physical therapists. Another aspect of the haptics that we're looking at is force perception, trying to understand how you can feel and portray a force to someone else. So looking at, here we have an individual looking at these Omni devices. These are force feedback devices that we program, and you can feel virtual environments. So you can interact with different worlds around. If you look closely, there's a bunch of spheres on the screen that he's interacting and pushing around. And we're looking at how you perceive forces in different directions. Depending where you push and where you feel a force, it's not always the same. Depending if you are being pushed upon or whether you are pushing, so passively receiving a force or actively generating a force, you'll perceive that force differently. So there's a lot of the neuroscience and mechanoreceptors in the hands that cause these effects, and that's a lot of what we are trying to understand is this fundamental aspect of force perception and being able to recreate it. Now moving a little bit on to some of the rehab. Here is the Karen system that Dr. Carey talked about 7 minutes ago. So you notice here, it's got a nice big screen, so you can put a virtual reality display in front of you. The platform can move, so you see this individual with a prosthetic leg walking on it. And we can simulate things like dropping or stepping off a sidewalk. So it can all of a sudden fall to one side, and they're going to feel that and continue walking. It has this split belt treadmill, so in a second you're going to see her walking, and we stop one of them, and this simulates tripping. So in this study, we're looking at someone who has an above-the-knee amputation wearing a prosthetic. We're trying to understand balance and how well they can recover from some of these aspects. But this is what the Karen will let us do, is to simulate all these different environments. Now it has a motion tracking system, so we can actually measure up to 64 different markers throughout the body. And so it is a very useful platform for looking at this. Now, it's a very expensive platform, which is great for research. But again, I like to bring things into a practical, useful thing that, particularly for rehab, would be able to go home with someone. So one example of this is the split belt treadmill is useful for helping people with a stroke. A stroke is kind of like you get a line down your body one side of your body is impaired, the other one is still fairly normal. Now, the split belt treadmill can restore walking ability in these individuals by focusing the walking on that leg that needs it. In much the same way, the iStride device is essentially a split belt treadmill applied to the bottom of one foot, but it lets you walk around. And this is, on the bottom right, you'll see an individual walking who has had a stroke, and we've actually finished up a clinical trial with 21 individuals with stroke using this, and it has shown very, very good results. So this is the example of taking the split belt treadmill that's in this big expensive Karen system, finding something and applying it to a little device right here that you can bring home that has that same rehab ability. So we want to be able to have them go home, use it, they can use it more often, and we're starting to see people walking better because of this device. Now, a lot of this research we do is in this vein, but sometimes we want to show it off a little bit and have a little fun. So here is a very large version of the iStride device that my grad students built in a couple days when they were trying to figure out a way to demonstrate it. So sometimes we build toys, but most of the time we're building research that is designed to help people regain their abilities. So again, if you have any questions and you'd like to talk to me, please go to my website at the top right or search for Reed Lab at USF, and please get in touch with me. There's a link to my email, and go try the Pat and Rub app to feel what some of the stuff that we do in my lab. Thank you.
Thank you, Dr. Reed. Again, if you guys have any questions, be sure to post them in the Q&A section. Next up, we have Dr. Nancy Diaz El Saeed. Get her going. Sorry, guys, sometimes it's a little sticky here. There we go.
Awesome. Hi, everybody. Let me just go ahead and start sharing my screen.
All right, good stuff.
Okay, awesome. You can see the screen, Celeste? Okay, so welcome. So my name is Nancy Diaz El Sayed. I'm an assistant professor in the Department of Mechanical Engineering. I just joined this fall. And I run the Smart and Sustainable Systems Laboratory. Right now, we have a team of 3 researchers, a PhD student, an MS, and hopefully soon to be PhD student, as well as another MS student. And today I'm going to be talking about the projects that that they've been working on and that motivates the work that we do for manufacturers. So much of the work that I do is really to help enable small and medium-sized manufacturers to optimize their operations by leveraging smart manufacturing technologies. Prior to joining USF, I worked for Autodesk for a few years, and so I had a chance to engage with customers, you know, at the small and large end of enterprises and identify some of the challenges that they were facing when trying to implement more of these Industry 4.0 or smart manufacturing technologies. And it's really distinct between the small to medium-sized manufacturers and the larger enterprises. So essentially, a small and medium-sized manufacturer that will have fewer financial resources available to them. They don't necessarily use as many advanced manufacturing technologies as a larger one would. They have low R&D, low research and development within their facility. And though their product specialization could be very high and in fact higher than that of a larger company, they don't have necessarily the same breadth of knowledge and experience that a larger company would, who would also have, you know, available financial resources to reach out to consultants or technology integrators in order to initiate advancements within their facilities and improve operations overall. So we're really targeting solutions that can help add value to manufacturers, that are accessible, and that'll make a difference overall. So when we speak to manufacturers, one of the primary factors that are motivating decision making, in addition to safety, is of course the quality of the parts that are being produced. And so one of the projects that is ongoing within our lab is on tool condition monitoring. And so we're looking at investigating different degrees of data resolution and features, applying machine learning techniques in order to identify the degradation of a cutting tool in real time over time. That way, if we know that a specific cutting tool that is in operation cannot achieve the features necessary to produce a pre-specified part design, given the tolerances of a customer, then we can advise the operator to change their cutting tool. And so related to this project, we're also looking at how to make recommendations for data requirements of alternative smart manufacturing use cases. We don't want our manufacturers to end up with big data lakes with a lot of data that's irrelevant, but really to narrow down the data sets within their facilities so that they could make informed decisions across their operations. And so the video that you see on the right is of a CNC machine tool, and we're plotting power consumption over time. And you can see that there's a distinct variation within the power demand. So as we turn on the spindle head, we see a peak in the power demand. As we start moving the table axes, we see variations, and then we see these hills in power demand as we're cutting. So power demand is one of the features that we will be tracking within our laboratory for tool condition monitoring experiments. Another project is developing a framework for smart manufacturing that considers multi-criteria decision-making processes in order to help a manufacturer decide whether or not to invest in a new system or a new solution for their facilities. And so we're using as a use case part quality, specifically additively manufactured parts, and we're making a comparison of conventional techniques versus smart technologies in order to see if the return on investment, resource consumption, and ultimately the value of these solutions make sense for a manufacturer to invest in. And so we're considering the adoption methodology of different sized enterprises, the maturity levels for Industry 4.0 readiness, and key performance indicators that span a number of different categories, including the performance, social conditions like the safety within the facility, sustainability conditions, for example, the costs, energy consumption, greenhouse gas emissions. And so overall, we're creating a framework that considers multiple sets of criteria for these solutions and comparisons. And then the final project that I have a student working on is related to precision manufacturing and predictive diagnostics. So they're working on building a computational fluid dynamics model of the inside of a factory. And so here we can see thermal dissipation within the factory. And so ultimately we want to be able to have a scalable CFD model of the factory that can account for airflow, thermal gradients, and pollutant dispersion. So we'll be streaming data from inside our laboratory. The hope is to ultimately pilot with industrial partners and modeling process and environmental conditions. But we want to use this information in order to inform optimized production scheduling strategies. So if we know that the thermal gradient is too high at a specific time of the day, then perhaps we don't want to machine parts that require very high tolerances during that time. Then we could shift that time to cooler parts of the day, just to give an example. Follow-on part of this project is also to investigate how cutting parameters, the machine operation, and these environmental conditions influence the rate of degradation of CNC machine tools and their subsystems, with the ultimate aim of offering real-time maintenance strategies to our manufacturers. So that's it on my end. If you have any questions, I'd be happy to answer them, or you could always feel free to send me an email. I've noted my email address here, nancyd1@usf.edu. Thank you.
Thank you. So next up we have Dr. Ying-Ser Zhang.
Okay, good. Hello everyone, let me try to share my screen here. Still waiting for it to load here. Yes.
There we go.
Can you see my screen here?
There you go.
Okay, perfect. Okay, hello everyone. This is Dr. Sarah Zhong. I'm an assistant professor from Department of Mechanical Engineering. So today is a great pleasure to share our lab and the research we are working on with every one of you. So the lab I established in the Department of Mechanical Engineering in 2019 is called Usf Green Lab. So in this Green Lab, we are conducting green research for energy efficient innovations. So that makes GREEN green, and that matches with the same color of our university. So today I would like to share 3 major research directions in my lab. The first one is a very interesting one. It reacts to the ongoing COVID-19 pandemic. And this project attracted a lot of attention from the media and also NSF. We also delivered our information to 2 congressmen and multiple media journalists. And so where is the secret? The secret is we are using corona discharge to fight coronavirus. So we are trying to address the shortage of masks and the shortage of disinfectants. So how it works is corona discharge is powered up by a high voltage power supply. However, it's safe and a low power input. And after we apply the corona discharge on masks, then the mask will be disinfected. Also, it will get recharged to restore the very high filtration efficiency. So it compared to other disinfection technologies, it is non-contact, non-chemical, and low cost. So with this technology, we have been able to repeat the treatment for 15 times, and the filtration efficiency of 95 masks kept around 95%. So it is a very safe and very useful technology to address the shortage of masks and disinfectants. So in the future, we are looking to explain the working mechanism of this very special disinfection technology. So that means we need the students to with backgrounds of mechanical engineering and also biological engineering to help us to address those very interesting technologies. And especially recently, we discovered that this corona discharge can break the DNA of those bacteria and viruses. So that will be a very interesting topic to work on. The next project I would like to share with everyone is the very large project. It's named Personalized Closed-Loop Wearable Healthcare Systems. So we are dealing with a lot of signals from our body, such as EEG, EMG, and that represents our organs, including the brain, the heart, and every piece of muscle in our body. So we have a very specially developed printing technology in our lab, and we have already submitted 2 patents. And with this technology, we have proved that we can print different kinds of materials, including conductive materials, and to make those sensors sensitive to strain, very sensitive. And also, we can test the acoustic signals, including the strength and the frequency, and also we can test the temperature change. So in the future, we are looking to allow our sensors to test the chemicals and the gases. This technology has its benefit of being able to be to realize roll-to-roll manufacturing and also nano manufacturing. And the final goal is to help us to realize personalized closed-loop wearable healthcare. Here, personalized means we're integrating our technology with machine learning to help us to address health issues for each individual. And closed loop means we can, sorry, that's my cat. So we can address the issues from the sensing to diagnosis, and also the final treatment for everyone. So the third technology I would like to share with everyone, it's also a multidisciplinary and very interesting topic. It's 4D printing technology. 4D printing here actually means we use 3D printing to print shape memory polymers. So here that makes the 4D as the time, which means under external stimulations, the shape of the structure will get changed. So by leveraging the advances from 3D printing and shape memory polymers, we will have two major directions. One is energy harvesting robotics to address the very serious carbon dioxide emission problem for the entire world. And also the other very interesting topic we will work on, and we are currently collaborating with multiple researchers, is directed dynamic organ growth. So the final goal is to, again, realize personalized healthcare. And if you are interested in those topics, please feel free to contact me, and this is my contact information. And finally, this is the very great team I'm working together with. So right now I have 4 PhD students, 1 master student, and 2 undergrads. And one of the alumni from my group, actually, he got his internship in his dream company, Tesla, and he finally found his job in his dream company. So I will be very happy to help you with the success of your career and research. Thank you very much.
Thank you. Please continue to post any questions you guys have. Next up, we have Dr. Wenbin Mao.
Okay, good afternoon, everyone. Okay, so let me first share my screen.
You're good to go.
Good afternoon, everyone. My name is Wenbin Mao. I'm an assistant professor in the Department of Mechanical Engineering. And it's my pleasure to give a short introduction of my lab. It's Biofluid and Biosolid Modeling Lab. And this lab was established in fall 2019. And for more information, you can find on my website at bsm.eng.usf.edu. Okay. So the research of this lab is focused on biomechanics of heart valves, myocardium, and other soft tissues. For example, this figure shows the full valves of human heart, and this shows the fibrous structure of myocardium. This lab is also interested in studying the fluid dynamics in the area of biofluid flows and microfluidics. For example, the animation here shows the blood flows through the aorta, and here this figure shows the design of a microfluidic device with the help of computational modeling. So this device can be used to separate cells with different stiffness. And we're mainly using 2 computational approaches in our lab. One is finite element analysis for the solid mechanics, and the other is computational fluid dynamics for the fluid flow. And if these 2 methods are coupled, we can solve a lot of problems involving like fluid structure interactions. For example, like the blood flow through a soft aortic valve, and also the interventricular flow in the beating human heart with 2 heart valves. Okay, I will briefly talking about 2 ongoing projects in our lab. One is the modeling of ventricular myocardium. The objective of this study is to develop a physics-informed machine learning model to evaluate and predict the behavior of a beating heart in a cardiac cycle. So first, it's because it's a physics informed. So we first establish a constitutive model. Right here we consider both the passive material response of the myocardium and the active contraction of the myocardium. And for the passive model, we adopt a well-known model from Hozafo, and the benefit of this model is it can capture the behavior of muscle fibers through the cycles of myocardium. And for the active model, we introduce a parameter called contraction parameter gamma here in these equations. Then here with these models, we conduct hundreds of finite element simulations with varying the material properties and the fiber orientations here. Then we use a database. We use the generated database as a training set for to train a machine learning model. We find that the random forest regressor model gives the best results. For example, here is a representative pressure and the volume waveform from a normal human heart. And clinically, this pressure and volume waveform is used to evaluate the function of the human heart. And here, this green line shows the model predict gamma, which is the parameter of our model. And with this model, we can predict a very accurate volume waveform, right? This blue line is the model predict value, which is very close to the predetermined value. So it means the machine learning model gives very accurate results. Here is the gives two animations of a simplified myocardium model. This figure shows the total displacement, and this figure shows the effective stress of a myocardium under pressure load in a cardiac cycle. As you can see, when the time is around 0.25 seconds, the myocardium reaches the smallest volume, and then because it represents or it corresponding to the strongest active contraction, which happens at the peak systole. So another project is the CFD simulation of the blood flow in the aorta. Aorta is the largest artery in the human body. Okay, in this model, we first established our geometry from the segmentation of the clinical images, such as MRI or the CT scans. Then we reconstruct this model by smoothing it. And then we created the CFD simulations of the CFD models from this geometry with some simplifications. But we considered the time-dependent velocity profile in it at the ascending aorta. As you can see here, the flow condition is quite complex. It shows the velocity profiles at different locations and at the different phases. And this figure shows the volume rendering of velocity field through the aorta. As you can see, it generates a lot of small vortices in this flow. Okay, and one of my future work in this lab is to develop a whole left heart model, integrating the hemodynamics, structure, mechanics of the valve, and the active contraction of myocardium. And with this comprehensive model, we can simulate the surgical intervention of patients with heart diseases, and we may help the surgeons to predict the outcome of their treatment, and may use as a pre-surgical planning tool in the future. And currently, my lab has one opening for PhD students starting from the fall 29 this year. So if you are interested, I encourage you to go to my website and find my contact information. And okay, thank you.
Thank you. And last up, we have Dr. David Murphy. And when you're ready, you can share your content, and I'll go ahead and put that up.
Okay. We're good to go. So yeah, I'm Dr. David Murphy. Hello to all the students out there who are thinking about grad school as an option. I'd like to tell you a little bit about my work here in the Murphy Fluids Lab. I'm David Murphy. I'm an assistant professor in mechanical engineering here. And the goal of my lab is to explore the role of fluid mechanics in biology, ecology, and the environment in order to find inspiration, often bioinspiration, for solving human engineering problems. So this is a really broad area of work. We work with a wide variety of collaborators, including biologists and oceanographers and public health experts. And our research really takes us all over the world. We currently have research projects in Bermuda, as you can see on the left, Antarctica, and at the Keys Marine Lab as well. So quite a wide variety of locations. So I want to talk a little bit more about some of the research projects we have going on right now. So we're very interested in animal locomotion, with the idea of eventually developing bio-inspired robots that have some of the capabilities that animals do. So we're working on flapping flight in air and in water. So on the left-hand side, we have this high-speed video of a fruit fly flying, and then in the middle, we have a high-speed video of a sea butterfly. This is a little marine snail. And on the right-hand side, we have a soft robot model wing that we're developing based on the motion of these sea butterflies. So we're basically interested. Oh, yep.
I think the presentation is not showing.
Yeah, your content hasn't showed up.
Content, share content up there, right next to leave, you know?
Oh, let me try that again. Okay.
Yeah, maybe there's a glitch.
It's not just the share. Let's see.
Like the typical Microsoft Teams, you know? Like
yeah.
Share and then share your PowerPoint.
Okay, that is what I did there. Let me try sharing my desktop here. Instead, maybe that'll work.
That's working.
I think it's coming. Yes, David, you can now proceed. Yeah.
They did give us a warning. We have 5 minutes left in the meeting. I think it will automatically close. So if you can give us 5 minutes, Dr. Dubé, that would be great.
Okay, I'll go pretty quickly then. Okay, so Murphy Fluids Lab, research all over the world. We do animal locomotion, looking at how to basically get inspiration from these animals to then design really cool robots that can do similar things. So here's the sea butterfly, our little insect, and a soft robot wing. We're also interested in collective behavior of multiple organisms. So our model organism for that is the Antarctic krill. So that's one of the reasons we go to Antarctica, which you can see here. And so here you can see all these krill swimming together. We're studying how they swim together with the idea of eventually developing swimming robot swarms. We're also interested in COVID. That's a very hot topic right now, very interesting. And so we have a little COVID simulator, or a breath simulator to study the aerodynamics of COVID transmission. So that's an active area of research. And then finally, we also do environmental fluid mechanics. So we're interested in oil spills, looking at how to clean up oil spills with chemical herders, as you can see in this video on the lower left-hand side. And then looking at phenomena at the ocean surface, such as bubble bursting, as you can see on the right-hand side there. So a lot of high-speed visualization, a lot of flow measurements that we do. So if you're interested in learning more, feel free to email me. Thanks.
Thank you, Dr. Murphy. Now we're going to have our department chair speak with you all for a moment, Dr. Rajiv Dubé. And I do just want to let you all know, feel free to check out the department website for any faculty's research lab websites.
Can you guys see me?
Yes.
Okay. I'm live. Yeah. Hello, everyone. I'm Rajiv Dubey. I'm department chair for mechanical engineering. I'm also director of the Center CART, Center for Assistive and Rehabilitation Robotics Technologies. And I believe Dr. Stephanie Carey may have talked about it earlier. Is that right? So
that's correct.
Yeah. So I guess we have a couple of minutes left. I just wanted to welcome everybody and hope you will apply to mechanical engineering graduate school here. And as you can see, we have research in lots of different interesting areas, from robotics and prosthetics, advanced materials, nano manufacturing, computational fluid dynamics, biofluidics, advanced manufacturing, data-driven sustainable design, and so on. So there are so many different, and all these research projects are funded by National Science Foundation, Department of Defense, a lot of other agencies. Also, we work with the private sector, and I'm assuming Dr. Guldikan has already talked about the process and all that, but really, just to welcome you to apply, and if you have any questions, please contact Dr. Guldikan or me, or directly some of the professors. You can go to our website and you'll get all the contact information. Okay. Dr. Guldikan, you have the final words to say something? You are muted. Yeah.
You're live.
Thank you again for joining our conversation. I think now we have the virtual campus tour. I think I hope that you enjoyed all the talk that we gave, including all the faculty members talking about their exciting research work and all. I gave you my email. Feel free to reach out, okay? And thank you for joining. I think this is the end of this session. You need to go back to the Microsoft Teams main page, right, Celeste? How do they go back? Do you know?
Yes, they will have to go back to the open house for the campus tour, which the link should be provided in the email that they received. So if you got questions, just let us know.
And then you got to end with Go Bulls, right?
Go Bulls. And then, all right, everybody, have a great day, okay? Thank you for joining again.